So for the next speech in this room, a very warm welcome to Tarus Balog. I hope I pronounced it right now, Tarus Balog.
Yeah.
As you already can see, he is from OpenNMS, and he will tell us a bit about what's happening with OpenNMS. Thank you.
Thank you very much. Thanks, Toby. Hi. Let me see if I can get this volume right without scrambling anybody. I'm sorry, the Balog name's Hungarian, and so I move around and I use my hands a lot, so I'm going to be bouncing. I know that I have to stay in between the two signs, and we should be good. My name's Tarus Balog. I'm one of the maintainers of the OpenNMS project. How many of you have heard of OpenNMS? So we have some new people, which is good. OpenNMS was started in 1999, and we did our first commit on SourceForge in 2000. So this puts us about the same age as Nagios. Nagios was registered on SourceForge in January of 2000. We were registered in March of 2000. So I'm here today. I'm not here to give a huge introduction to OpenNMS, but a lot of stuff has been happening with the project, and I just wanted to share it with you. I'm also known as the mouth of OpenNMS. I could quite literally talk for the next 7 hours and not take a break. And so I think it was strategic that they put me just before lunch, so that since I also like to eat, I think that I will definitely finish in time for 1. I have a slide here just kind of giving you some overview of the project. The kernel, like the Linux kernel, brags about having thousands and thousands of contributors. We do not. But we do have around 50 core people working on the project. So it is a very active project. The way it works is a lot of the configuration gets updated with each release. So out of the box, if you point OpenNMS at your network and you have, say, SNMP installed, you will end up getting about 2,000 different objects will be data collected and graphed. And we have over 20,000 SNMP traps pre-configured with OpenNMS. So a lot of work going on with that. We've since moved, even though you can find us on SourceForge, we're with everybody else on GitHub. So here's a list of GitHub commits over the last 5 years. And as you can see, it's definitely going up on average. So it's a very, very busy project. So what's happening with OpenNMS? I love this conference. Oh, I meant to point out. So, you know, Disneyland may say it's the happiest place on earth, but I think Nuremberg is the happiest place on earth because all the buildings even smile. This is actually up near the Christmas market. I took that picture yesterday. I really love this conference because it brings together the best of open source monitoring. I mean, you've got Zabbix, you've got Isinga, you've got us, you've got all the new stuff. You've got Prometheus, you've got Grafana. And all of these projects are pure open source projects, and I like that a lot. So I was here last year in November, and so what's happened since then? Well, right after I left, we released OpenNMS 14. Soon after that, we released Horizon 15. In February of last year, or of this year, we released Meridian. Now, I'm going to explain what Horizon and Meridian mean in the next slide. In April, we released Horizon 16. We have an annual developers conference called DevJam. We had our 10th conference. So very few projects can point to actually having a 10-year track record. This conference can point to having a 10-year track record. And then coming up this week, I think it's this week, if not, it's the first of next week, we're releasing Horizon 17. So there have been a lot of releases of OpenNMS. Now, I work for a company called the OpenNMS Group, and we do services and support around the OpenNMS project. That's how we make money. That's how we're able to keep OpenNMS running. We have a bizarre business model. It's called spend less money than you earn. Now, that sounds crazy, but it's kept us around for quite some time. Well, running a support business, running a services business can be difficult, and we were trying to solve a couple of problems. One problem we were trying to solve is how can we release OpenNMS more quickly? We had been doing a stable OpenNMS release every 18 months, a year and a half, which is a long time. But the problem is I run a support business, so if I'm churning the code a lot, that makes a lot of extra work for me and my team. So we adopted the Red Hat model. And I'm talking about this today because I want to stress that both versions of OpenNMS are 100% open source versions. So as most of you know, Red Hat probably has the best open source business model out there. They're a $15 billion company, and pretty much every piece of code they write is open source. That's why we have CentOS. CentOS is able to take Red Hat's code, pull out all the trademarks, recompile it, sell it, and it's function for function identical to Red Hat Enterprise Linux. So we split OpenNMS into two versions. So we have a version now called Meridian. That is the Red Hat Enterprise Linux version. And we have a version called Horizon, which is the Fedora version. And that's why we've had 4 major releases of OpenNMS in a year because of this split. Most of our support customers are moving to Meridian, and that is more of a once-a-year release cycle. We call it Meridian 2015. But it's kind of hard to get this across in a slide, and as people who do know me, I hate like the open core model, where here's a little bit that's open source, but if you want all these cool features, you've got to pay us money just like a proprietary software company. So I wanted to stress that's not the plan. We do charge for access to the Meridian code, but once you own it, it's yours, you can distribute it, you can do what you want with it. Enough of that. Why did we do this? Red Hat. I actually got a meeting with Jim Whitehurst last year. I have a man crush on Jim Whitehurst. He is like the greatest, nicest man you'll ever meet. He came from Delta. He came from an airline industry, and he runs the world's largest open source company. But I took this picture last Wednesday, and their market cap is close to $15 billion. And they're still a pure open source company. And that's what we strive to be as well. A $15 billion, no, I'm just kidding. So what came in OpenNMS? OpenNMS 14, which we released last year. Well, one of the things that I point out first, we actually have documentation now. I know it sounds strange, but we do. It's not perfect, but it is so much better than it was. This is an actual screenshot of the page concerning our DHCP monitor. So we've got little pictures, we've got examples, we've got code examples, and you can go to docs.opennms.org and actually see documentation. It's written in ASCII doc. It's compiled right along with every release of OpenNMS. So if you're trying to get started with OpenNMS, you now have a few more tools to help you do that. Now, we also changed the license. OpenNMS had been published under the GPL version 3. We switched to the Affero GPL version 3. Mainly, we saw a lot of people in our IRC channel. I don't say a lot, but a number of new people would show up in our IRC channel, and they were obviously trying to find a way to monetize OpenNMS as a service. Like they were going to brand it, put OpenNMS out there, and charge people for it without sharing the code. We don't believe in that, so we asked our community, what should we do about this? And one of our community members said we should switch the license to the Affero GPL, which closes that loophole. It's the main reason we do that. So just wanted to bring that up. Now, OpenNMS Meridian is available under the AGPL. One of our customers, I'm being recorded, so I'm not going to say the names of our customers. You can ask us. You can ask me privately. But one of them they won't allow any AGPL software. So I went to Aaron Williamson, who used to work for the Software Freedom Law Center. He's our lawyer. And I said, hey, I want to write up a proprietary license that's exactly like the AGPL. It gives you all the rights, except you can't make a service out of it. And so you can choose that license. And that's enabled us to get a few customers who wouldn't normally choose the AGPL. Now, how many of you like network maps? Oh, come on. You've got to at least have a boss who's like, I want to see the map. I want to see like where the space shuttle is in JPL and stuff like that. Because we always got that. I hate maps. There was a time in my life where I was having to work with Network Node Manager, and all I did for hours was drag objects into containers on maps. And I really wanted to kill myself. However, OpenNMS has some pretty cool maps now. Starting with OpenNMS 14, we have a topology map. So we discover using a thing called enhanced link D, we discover links layer 2 links between devices. Now, of course, I had an outage here. Ike is actually my soda machine. This is a little slow because all you guys were downloading torrents last night. But Ike is a soda machine that I monitor. So when I sell sodas, we actually keep track of how many Cokes have been sold and stuff. We drink way too much. But what this enables you to do is actually migrate through the network at layer 2. And the more objects you bring in, you'll see, here's this SSH outage just cleared on here while I did that. Otherwise, you'd see a little icon over here. You can change the layout, you can change the format, etc. So it's kind of cool. And this is designed to show you relationships at a layer 2 level. The topology is actually an API. And what we have is, if you happen to use vSphere, if you use VMware, you can see a VMware topology. So you can actually go in here and see your network attached storage, you can see your host machines, you can see your guest machines. Juniper is actually developing an API plugin to show all the PVCs through their network. So we're hoping that as OpenNMS matures, the topology API will mature along with it, and we'll have a bunch of other plugins. Now, the other type of map we have is a geographical map. So it shows you your locations. And we use the tiles provided by OpenStreetMap, but you can use MapQuest, you can use Google. As you can see, if you mouse over here, it'll show you the area. You get, this is a group. It says there's 9 devices in here. Most of them are green. As you zoom in, you'll see things split out. So all the devices split out. That little 2, that's my house. So I'm monitoring 2 nodes in my house. And if you drill down, it'll show you what the current status of these devices are, and here's your alarms here. If you happen to zoom out, what will end up happening is you'll always see these things kind of group in together, usually at like the state or county or district level. If there's only one device, you'll get the little pin, like up there near Portland. We have a server up there, but there's only one server, so it shows up as a nice little pin. So again, it's really good for those JPL maps where the boss wants to see a design of what's going on the network. We also added in 14 this idea of ops boards. I should have made a video for this, but I just learned how to do it, so I didn't. This allows you to create screens that you would put up in a NOC that rotate. So you could have your alarm list, you could have an alarm summary, you could have something from a news website, and these can rotate. And so one of the nice things that's cool about the ops board is that you can set up events where it'll change the priority. So let's say you have an alarm, a critical alarm pops up, it can increase the priority of that board, it'll show up more often. So let's say everything has a priority of 3, you get board 1, board 2, board 3, board 1, board 2, board 3. If we get a critical alarm, you get board 1, board 2, board 1, board 3, board 1. So something interesting there. Again, trying to get information out to people who can use it. Now, in OpenNMS 15, we focused on one thing, the web user interface. Our web user interface is not the prettiest thing in the world. The maps I showed you is probably the first thing we've done in years to make them pretty. The technology that we used was, again, from 1999. We ended up migrating the entire web UI to a technology called Bootstrap. And Bootstrap is a very responsive web interface so that you can shrink and enlarge the screens. We ended up having to touch every piece of the web UI. So this is like the normal web UI. If you were to scrunch in this, they would line up in order. This is the same web page on my phone. So as you can see, it's all very, very useful to interchange between different technologies, different devices, etc. Now, one of the reasons that we haven't in the past focused too much on the web UI is that the vast majority of our large customers don't use it. OpenNMS has a very strong REST API. And so usually what happens is that customers will have their own internal system. They will make REST calls to OpenNMS to both provision OpenNMS, get alarms, delete things, etc. So the other half of 15 was we really beefed up the REST interface as well. So this enables us a very high level of integration with a bunch of different tools. So OpenNMS 14 was mainly on our maps and enhanced linkd. OpenNMS 15 focused on the web UI. So what's cool in OpenNMS 16? Compass. And I have actually, we have the Compass logo, which I don't have on this screen here, but we have stickers. So I know everyone likes stickers. This is the Compass logo right there. Compass is our new mobile app. So it's free. You can get it on iOS and you can get it on Android. This may be the direction of the OpenNMS web UI. We use a technology called, I think it's called Ionic is the library, which enables us to write once and publish to both iOS and Android. This is a really, really cool tool. You should check it out, especially if you open NMS. The only downside is from your phone, you need to be able to talk to OpenNMS. So you either have to have a hole through your firewall or you've got to have a VPN. That's the main downside of it. But you can see your alarms, you can see your outages. One of the cool things is if you remember the map, you can set the coordinates for your device from your phone. So if you're at a remote site or if you're in your server room, you can pull out your phone, you can hit set coordinates, and it'll go ahead and it'll set the longitude and latitude of that device on the map. The other thing that we can do with the latest version of Compass, you can have multiple servers. So we have two here, demo and internal. If you switch from internal, which is a Meridian server, to demo, which is a Ryzen server, the colors will change. So now it's all green. One of the things we added in Compass was the ability to favorite graphs. So this little movie here is actually demonstrating how you can go through different nodes, pick out which graph you want, and you heart it. You basically put the little star next to it. It'll bring it up. You can mix and match. So I can take CPU utilization. I can take load averages. The other thing that OpenNMS collects is latency data. So here's a load average. When we do a poll, we collect the time. We do the poll. The moment the poll returns, we grab the time again. We store that in a file. And so we can determine how long it's taking us to, say, access a web page. And you can, of course, threshold that as well. And if you threshold that, you can get an alert before you have an outage. You can get an alert when a threshold's getting close. Now you come to your favorited graphs, and you can just swipe through them. And you can see all your favorited graphs. You can also change the time series. So you can change the start and stop time. All this from your phone. You can be down at the pub, and you can be having a beer, and you can be checking on your CPU utilization. You can change the time range, etc. Again, all of this is free. And it's part of the OpenNMS Compass product. This got us a BOSSY. InfoWorld has a Best of Open Source Software Awards, and this is the screenshot from the BOSSY page, and as you can see, they really highlighted Compass because it puts the power of your network management system right in your hand. Another thing, did anyone go to Torkeld's Grafana talk? So this morning, Torkeld did a Grafana talk. We integrate with Grafana. So we act as a Grafana data source. You can enable it, you can point Grafana at OpenNMS, and you can gather all this data. Have multiple instances of OpenNMS, you can put multiple instances on one page. And if you haven't played with Grafana, it is a really, really cool system. We have been worried about trying to visualize all the data that OpenNMS can collect. And the Grafana integration really enables us to do that. We went to a trade show. The Wi-Fi here hasn't been bad. Has anyone had just really bad problems with the Wi-Fi? The VLAN? I'm surprised. Most trade shows I go to, it's just dead. You end up getting 1,000 geeks in a hotel, and it's just like, it's dead. We went to a conference called SELF, the Southeastern Linux Fest, and we set up Grafana to monitor their network. And so here's all the different access points here and how many people were loaded in. We're tracking the number of people associated with each access point as well. And we had a booth. We actually had a booth itself, and I love booth duty, we call it, sitting in a booth and talking to people, but it can get old because you're there for like 8 hours a day for 2 days. And so on the last day, we all wanted to go home, so we looked at the number of people connected to the Wi-Fi, and when it dropped below 50, we left because everybody else was leaving. And so he said, if there are less than 50 people connected to the VLAN, then we're going to leave. But again, getting this stuff set up is just very, very easy. And so if you need a visualization tool, I strongly recommend you look at Grafana. So OpenNMS 14, we were talking about maps. OpenNMS 15, we've got an entirely new web interface structure. In 16, we've got graphing, we've got compass. What's coming in OpenNMS 17? So OpenNMS 17 is coming out, I believe it's next week. We're aiming to be the de facto platform for the Internet of Things. We can monitor millions, if not billions, of devices. And we want to be the platform that people choose. One of the problems we have with this is performance data storage. We use RDTool as our backend. A lot of people, Cacti, almost probably everyone in here who's done anything with network management has been exposed to RDTool. The problem is it's a great tool. I mean, it does great graphing, it's very compact, but it doesn't scale. So we were like trying to figure out how can we scale to literally billions and billions and billions of devices. Well, we came up with a project called Newts. You can read about it here, newts.io. This is our cool crowdsourced logo. Get it? Newt. Newts is a time series database built upon Apache Cassandra. How many here are familiar with the Apache Cassandra project? A few hands. It was invented by Facebook and contributed to Apache. Both Newts and Cassandra are Apache licensed, so it's a very permissive license. The guy who worked for me who was the principal architect of Newts, he left. I don't have many people quit on me. I've had to fire a few people, but I haven't had any people quit on me. But he went to work for MediaWiki. And since I can't make a blog post without a Wikipedia article, I really don't blame him. I think he's having a very, very good time. But because MediaWiki uses Cassandra a lot, we're getting contributions. So we have contribution from outside of the OpenNMS project on Newts. Cassandra is massively scalable. We have a 3-node Cassandra instance in our lab, and it's hard for us to keep it busy. That's just how fast this thing is. And you can have multiple instances in one location. You can also distribute them across the world. And it'll replicate, it's masterless, it's just a wonderful, wonderful piece of open source technology. You put a time series database on it, and you've really got something. Because now we can store tons of data. And you can keep it pretty much as long as you want. The other thing is now we store the raw value. One of the complaints people have about RDTool is it does averaging. I don't know if anyone's ever run into that. But we store the raw value, and then you can use whatever smoothing function you want afterwards. You could use Grafana. As Torkel was showing, you can choose different functions to apply to the data. And so that's what's going on with Newts. Now, the issue we have is that we use RDTool. RDTool also provides our graphs. So just having the data in a different storage doesn't help us. It was funny, the first go we had at this, we would actually go to Newts, grab the data, dump it in an RD file, and then display it. So instead of doing that forever, this picture on the right here is your standard RD graph for system memory stats. We've written a JavaScript library called Backshift. And what Backshift allows you to do is to take time series data and display it. And we use the same exact syntax. So if you've been used to doing RDTool graphs, you can actually do the same thing in Backshift, and you get graphs like this. And as you can see, they're pretty close. What you can't do with RDTool is you're not able to mouse over. So with Backshift, if you mouse over, you'll get a little pop-up that tells you what the value is and what the two data points are, the time series on the x-axis and the y-axis. And if you migrate between, it's pretty sensitive, and you can migrate between each of those different things. So if you've ever wondered what that peak was, you can now look. Or you can also look at the raw data, something that was not easy to do with RD tool. All of this is from the Backshift library that comes in OpenNMS 17. And this works with RD tool or Newts. So it's another cool graphing aspect of it. I was thinking, I usually run long, but I'm going to run a little short today. OpenNMS 18. This is the next version of OpenNMS. We hope to have it out in the spring of next year. Now, as I mentioned, our goal is Internet of Things. So we've got the storage backend. So what's coming in 18? Well, we have a project called Minion. Now, I was just informed that Minion is being used by a number of different people. I will claim I was the first to use it in network management because I came up with this term about 20 years ago. And the idea was a minion would be one of these little processes that would go out and do some localized management. So it would collect events, it would collect data, it would process traps, it would do service monitoring, and it would forward that up to some sort of central console. And I called that central console Dominion because it has dominion over the minions. So, but apparently SaltStack uses Minion now, so I don't think this will be the go-to-market name for it. Our original project name was called Sneepo, which was OpenNMS backwards. And since we have a lot of people in Germany working on the project, they pointed out that's schnitzel and potatoes. So every time I look at this, it makes me hungry. But one of the things that I really love about open source and I dislike about the kind of open source, we call it, kind of the fake open source, is I remember there was I'm not going to name names because I'm trying not to be catty in my old age, but there was a company that's like, come to this trade show and we'll unveil the new stuff in our open source project. I'm like, unveil open source? I mean, don't you just, it's open source. So shouldn't it just be there? And so you can actually go, if you Google OpenNMS Minion, it'll take you to the GitHub project and you can see the code. So Minion uses something called OSGI. And OSGI is a technology that lets us dynamically change out bits and pieces of the process without having to restart it. There's a project called Open Daylight that's dealing with software-defined networks and network feature virtualization. Open Daylight uses OSGI. And so the idea is once the Minion, and my target hardware platform for the Minion is a Pi 2. So the idea is on really consumer-grade, low-end commodity hardware, you can put these everywhere. What I told the guys was, I showed you on the geographical map that little 2 where my house is. I want to be able to stick a Minion in my house, go to a web page, and be able to do everything that I normally could do through an OpenNMS GUI through the Minion, as if I had installed OpenNMS right there on the box. And we're close. We're really close. Because we really want to get to this. So there's been talk about making the banana swoosh like the default swoosh in OpenNMS. And yes, I did not license these little characters from Warner Brothers or 20th Century. I forget who did Despicable Me. But the idea is that as the Internet of Things comes about, we're going to need to have lots and lots and lots of collection stations. So if we can combine Minion with centralized deployment and management, along with the Cassandra and Newts backend, we should really be able to have unlimited network management capabilities. Now I have a final little movie here. One of the things that has always bothered me about certain open source projects is it's very hard to use. Like, they may distribute it via tarball. And so when every new version comes out, you have to get a new tarball, and then you have to backport your configuration changes. I mean, Git helps a lot with this, but I like RPMs, and I like just to be able to install RPMs. We make a repository for every single branch in our GitHub public repository. So here are all the different branches, and we support it for Fedora, for Red Hat. You could download the Sneepo branch. You could download the the Minion branch and use it. And every day that we had a commit, you could download and follow this right along. It is so incredibly simple. I mean, look how small this little thing is. I'm just dragging through all the different branches that we have in OpenNMS right now because we truly want to be an open source platform, and we want people using our experimental stuff. We want people playing with this thing. And so we don't hide anything. So there's no unveiling. We're not, ta-da! So you can play with this even as we speak. So, in conclusion, while I'm here with Zabbix and with Asinga and everything, we started out with our statement being, we want to be the default network management standard. We would like to be the network management platform of choice, which means we integrate with tons of things, both proprietary and open source, and that's our goal. Whether or not we succeed, I don't know. But I have 2 rules as we try to reach this mission. OpenNMS will always be free. There's not going to be an enterprise version. There's not going to be an extra version. Every piece of code that we write, that we call OpenNMS, will always be free. And the second thing is I don't want OpenNMS to ever suck. I don't want to be here next year going, well, we just had OpenNMS 20 because I wanted to release something for OSMC, not because it was ready. So again, we try very, very hard not to make OpenNMS suck. So go to www.opennms.org. You can check out the project. We have Debian packages. We have CentOS Red Hat packages. And if scalability is kind of something that you're concerned about, you may want to look to OpenNMS for that answer. This is me. So you can always email me, tarus@opennms.org. The social network I use the most is Google+, because it's only geeks. The only people who are on it, it's like my sister's not on it. I have lots of great conversations with Google+. I do have a Twitter account. I don't tweet very much. I usually tweet when I post to one of my blogs, and I tweet when I'm mad about something, because I found that if you tweet to like Marriott, they sometimes answer you back. Facebook, right. Don't do the Facebook. My open source website is adventuresiNOSS.com. I used to put lots of weird stuff there, like reviews of science fiction novels and movies. I have since moved that to tarus.io because all the cool kids have IO addresses, and I'm a cool kid. So, I also have a hobby where I make classic cocktails. So anyway, I'm just throwing that out here because I do believe there will be a small amount of drinking tonight. So if you haven't been here before, just be prepared, and those of you who have been know what I'm talking about. So anyway, that's it for me. Are there any questions? We do have a microphone, and
yes, if we have, please just give me a second to reach you.
So what I really want you guys to do is try and get this side of the room, so someone in the back corner asks the next question, so we can get Toby running back and forth here.
Hi. My name is Dennis.
Hey.
The last time I've seen OpenNMS, it was, I think, version 1.8 or 1.9.
Mm-hmm.
And what, basically baffled me the most, what people like about the less sophisticated monitoring systems like Munin or Nagios is that plugins are so easy to write. If I have some obscure piece of software, I can just put out a shell script monitoring the state of this obscure software and just integrate it into my monitoring system. I couldn't find a way to do this easily in OpenNMS. Is this going to change?
We hope to. We hope to. We actually have something I haven't covered in this, which is we're actually building like a little marketplace so that people can write plugins and put them out there. So that will entail having an easier way to do this. OpenNMS is written in Java. And I didn't make that decision. Usually that gets at least one groan. Oh, Java. But then there's people, I'm in Go. I'm like, okay. But I don't care as long as it works. When I teach the OpenNMS class, the way we answer the question, basically, let's be frank. It's a Nagios check script. How do I get a Nagios check script into OpenNMS? Well, we do support NRPE. So if you have NRP out there, that's fine. But I am a big fanboy of the NetSNMP project. And NetSNMP has a command called extend. And what extend does is run local scripts. So what I tell people to do is, if you have a check script or something you want to run, install NetSNMP on your server, set up your check scripts on the server, and then it's very, very simple to configure OpenNMS to A, discover that that script is supported on that particular device, and B, execute it. And so that's what I end up telling people to do. There is a general purpose plugin that is literally what you're talking about, where you spawn a shell and you run a script. We just found that in scalability, having to do a fork exec and run a shell and run a script every single time times 1,000, 2,000, 3,000 servers, it just didn't scale for us. Did that help at all?
Yeah, but basically the trouble with using SNMP is you have to come up with a MIP maybe, or at least an OID you are going to use. You have to configure it on the local node and on the central monitoring server. So it's a bit cumbersome.
Well, if you're going to use a check script that uses SSH, where you've got to configure keys on both sides of that as well, it's a trade-off. The beautiful part about NetSNMP's extend agent is we do a thing called that's a class example, and we call it class monitor, and the instance of the class monitor script is actually the word class monitor. So it's ASCII for C, ASCII for L, ASCII for A, and it's in dotted decimal notation. So it's really easy to know what the names of all these different scripts are. I use it for everything. So I'm one of the people who manages our internal network. And every so often, something will go wrong on my network that I didn't foresee. Like at one point in time, we have a server in the office. It's I call it like the vanity server. So if you have a domain name, and you want to host it, you can just host it on our server. So we have an Apache instance and everything like that. Well, we had a guy who worked for us who had his family domain on our server, and he wanted to forward mail to his daughters. He had 3 daughters, Carrie, Renee, and Emily. And so I just, mail would come in, I would forward it out to their Google account or something like that. Oh, it's actually their Time Warner account. Well, as young girls are wont to do, they visited a lot of websites. They weren't super careful about their username and password or their email address. It got harvested. So they were getting a lot of spam. So Time Warner thought I was a spam relay because they're monitoring. I'm getting a lot of spam from this address. Even though it was targeted, even though it was only email going to these 3 ladies, it was a spam relay. So Time Warner said, no more mail for you. Click. And so suddenly my mail queue got huge. We could not send mail to Time Warner. So I ran the mail queue command, and I could tell how many, there's like 800 messages queued up. So I wrote a little script that I plugged into SNMP that it just reported the number of messages in the mail queue. Just returned, basically returned that number. And then I wrote a monitor in OpenNMS. All configuration took me maybe 4 or 5 minutes. And it basically said, hey, if this exists on this server account, and if it's greater than 300, then the service is down. It violates the threshold. Another thing I do is, many years ago, we got attacked by script kiddies. I think there was a vulnerability in Apache or something that we had not patched, because I only manage like 30, 40 servers, but that's a lot, and you kind of forget, oh crap, I need to go run yum update or apt-get update on these servers. So I have a script that runs every hour through a cron job that goes and does a test. So it'll go out and say, how many packages need to be updated? And I store that in a file, and I just print that number out via SNMP. And so the service check is this value 0? If it is, the service is up. If that value is anything other than 0, it marks the service as down. I get an email, and I go and make sure that I update the server. And so that's how I do special checks, and I do almost everything through NetSNMP.
What are we going to do about Windows servers?
What are we going to do about Windows? You have Windows servers? You can start by getting rid of Windows servers. No, I'm just kidding. We do WMI checks. I mean, you can do data collection via WMI. You can do data collection via HTML. like what I do for my soda machine is I want to write an SNMP, a true SNMP extension for my soda machine, but I don't have time. So what I do is I just dump a file. So I talk to my soda machine and I say, okay, give me your inventory list. And it's this weird protocol called DEX. But it gives me this list out, and then I use a regular expression just to grep. Okay, that's slot 10, I've sold so many drinks. That's slot 11, I've sold so many drinks. And then I use our HTTP collector to go to a web page. So it's like ike.internal.opennms.org/drinks.text, which lives in the web root, and then I parse all those values, and then I do threshold checking based on that. Windows servers are an interesting case. You know, how do you? I'm not sure how do you manage it with Asinga or Nagios? Windows. Yeah. Well, we talk to NS Client. So we have an NS Client plugin. So if you like NS Client++, you can actually just configure NS Client++, and OpenNMS will run that check script through NS Client. So, yeah, we're trying to you know, I'm here at what used to be called the Nagios conference. So we do support a lot of the Nagios plugins. Any other questions? No one hates Java? Who hates Java? Come on, someone's got to hate Java. It actually works. I mean, one of our customers is, you know, we have telecom customers, and all of their tools tend to be written in Java. And so we're able to talk to JBoss and do some integrations at that level. But anyway, we still have a few more minutes, but that's not far. We're at the back.
Hi.
Hi.
I'm interested in the name of OpenNMS, so network monitoring. So responsible for network monitoring in our company. Do you have any recommendation how to start with your project in a network like 8,000 device from Cisco, Juniper, Brocade, different manufacturer, different routing protocols, OSPF, enhanced GP, ISIS, BGP, a lot of layer 2 stuff like spanning trees, so just install and enable auto discovery, or do you have any best practices or recommendation for this?
Yeah, you think I would have an easy answer for that. You know, like, how do I get started with OpenNMS? Well, we do have a tutorial on the website on getting it installed. But I'm actually working on a series of videos to help people get started. But basically, you install it. I would make sure that you have SNMP configured on these Juniper and Cisco devices. And then if you just point OpenNMS at it, either through auto discovery or through our provisioning system, you'll get an idea of what OpenNMS does, especially those two particular devices, Cisco and Juniper, devices from those vendors. We support them very strongly. So you're going to be getting memory statistics, you're going to be getting CPU utilization, temperatures, all those thresholds, everything's going to kind of work out of the box. And that's the thing about OpenNMS. It does a lot out of the box, but it really shines when you start to customize it. But there's an investment. I keep telling people it's free software. It's not a free solution. Because I keep getting questions on the mailing list. It's like, okay, how do you fix my network now? I'm like, I can't help you with that. I can give you the tools that you can use to help it. But that's that's our bread and butter, actually, is around the 7,000 to 8,000 device range. And again, all of the layer 2 stuff will automatically be discovered, and the way we do it is SNMP. So we look at the bridging table is one of the places, but there's all these specialized tables for both Juniper and Cisco that we look at. So you'll be able to see the interconnectivity between the two of them. And the topology map is really cool because you can actually add focuses, so you can focus on two disparate, I mean, my network is tiny, and if I zoom out on our map right now, you can't, it's just little dots. It's not very useful. So what we did with the topology map was allow you to focus on different devices and see the relationship between those two areas of your network versus trying to do the whole thing. But to get started, the wiki, so opennms.org, go to the install tutorial, point it at your system, and then we have, as I said, a very strong community. Most of it involves our mailing list. So we have a mailing list called the OpenNMS Discuss list. It's hosted by SourceForge. If you go to the wiki and type in mailing list, you'll see it. And it's very friendly. If you ask a decent question, you know, we have this one guy years ago wrote in, he's like, OpenNMS does not work. I've done everything. I've tried everything. It doesn't work. And here I am. I'm at the office. It's like 9 o'clock at night. I'm the only one in the building, and I'm sitting here, working with my customers, and reply. And I wrote back, "You're right. It doesn't work. We've got 30 million lines of code that compile, but it doesn't do anything. We did this to deliberately waste your time." And so, but of course we didn't. I mean, it does work, but it does. Getting over that learning curve is probably the biggest thing. Everyone's heard of Nagios. No one's heard of OpenNMS, and we're the same age. So one of the things I'm coming here, showing you some pretty little videos and things like that, is to hope I get you interested in it, to check it out. It does install, if you use a Linux server, it will run on Windows. I don't know if anyone saw there was an RMI exploit that someone posted. I was last week I was in Ireland. Go to my RSS feed, and there's all these news articles about OpenNMS and how it's vulnerable to this RMI exploit. Well, if you poke enough holes through your firewall and allow it to get to the OpenNMS box, then yes, there's a possibility that this is an exploit. And we've since hardened it even more in OpenNMS 16.04, which was released last week. But what the example they use was they use it to launch calc.exe. And I'm like, yes, someone got OpenNMS working on Windows. I'm like, that's amazing. It was just for an exploit, but mind you, the fact that it was on Windows was a little ironic to me too. But it's Java, so I had a bet with my developers. I'm like, okay, it's Java, it should run on Windows, right? So it took one guy 2 weeks to port. This was 5 or 6 years ago. It took him 2 weeks to port OpenNMS to Windows. The first thing he had to do was, there's a little bit of C code, because Java doesn't really understand the concept of a ping. And that's kind of important. I don't know about you. That's the first thing I do, is I ping things. The second part, so he spent a week doing that, got that to work, and he spent the next week getting the slashes to go this way. Or, excuse me, this way. Because we had just hard-coded the file separator character. So now it looks at the operating system, and it sets the file separator character to be where it's supposed to be. So that was kind of cool. One thing I want to stress is, you mentioned network management. Sometimes we get pigeonholed. It's like, well, I need to monitor servers, and you're a network management. When I say network management, I am treating the network like my 75-year-old father treats the network, which is literally anything on the other side of his keyboard. Network's down. Why is the network down? I can't get to my mail. Can you get to Google? Yes. Network's not down. Restart your mail client. What? Right mouse click, got him a Mac. Right mouse click on the little mail icon, hit quit, and click on it again until it stops bouncing. Oh, okay, it's working now. But, so when I've been doing this, I started doing network management in 1988. So I'm an old guy. And that was, we had network management, server management, middleware management, database management, but NMS, this network management, was always the umbrella. And so I want to stress that we do handle everything, all 10 layers of the stack. You guys know the top 3, right? Economics, politics, and God. So it's like, once you hit the application layer, money drives the next decision, politics can trump money, and religion always wins. So, any more questions? I welcome the opportunity to bore you even further. Thank you very much.